All right. So, other than the quiz in class today, we started out going over the ionic and covalent bonding worksheet. So, if you want to pause the video and take a look at this, so just a couple things that you can see. So, our first couple guys, are metals, okay, and they have fewer valence electrons. And we notice that they're all positives. So metals do tend to, or they will become positively charged ions, right? Where atoms are neutrally charged, ions are charged, right? They're positively, negatively charged. Chlorine, fluorine, these guys are non-metal, okay? And these guys both happen to be in the same group. And so they have 7 valence electrons, and they will end up taking one more electron. Why will they take one more electron? Well, they want to be a noble gas. They have that noble gas electron configuration. So if they take one more electron, they get a -1 oxidation number. Remember, this is just our charge. They get one more, and then that gives them their full valence shell that they've been wanting to. Okay, so here's the answers to which you guys should be turning in or should have already turned in. It's due by midnight tonight. Hopefully you guys got turned in already, though. But go ahead and check over your answers with this. Make sure you guys are doing it right, okay? Because I will be taking these for a real grade, okay? So the rest of these will be due for Thursday. And then here's these guys. So let's take a look at these guys. So we have sodium chloride, right? We have Na, and the only thing we're worrying about right now is valence electrons, right? So I know sodium has 1 valence electron. You're like, well, how do I know that sodium has 1 valence electron? Sodium's right here, right? Sodium is in group 1. All group 1 elements, we should know, have 1 valence electron. All group 2 elements have 2 valence electrons. So sodium's right here, 1 valence electron. So he has 1. Chlorine, how many does chlorine have? Let's go back to our periodic table. Chlorine's right here. He's in group 7, right? 1, 2, skip all of these guys, 3, 4, 5, 6, 7. He's in group 7, therefore he has 7 valence electrons. So Cl, 1, 2, 3, 4, 5, 6, 7. All right. And so where is this electron going, right? This is our ionic bonds. So remember, what's the difference between ionic and covalent from last week's video? Ionic, there's a giving and taking of an electron. There's no sharing, okay? And so when they do that, this sodium, right, we know this, right here, sodium is a metal, has 1 valence electron, gives 1, and then becomes positive. Chlorine is a nonmetal, has 7 valence electrons, will take 1, become negatively charged, okay? So these guys are a match made in heaven. Okay, so sodium will give this electron to chlorine, giving him chlorine that full 8 valence shell, becoming negatively charged, where sodium gives up its electron and becomes more positively charged. This negative ion, this positive ion, now they're really attracted to each other, right? We know that negatives attract, or sorry, not negatives. We know that oppositely charged particles attract, and this brings them together as an ionic bond, okay? And we know ionic bonds are very strong, actually. Magnesium, this one was probably pretty tough. So magnesium has 2 valence electrons. Okay, 1, 2. Again, how do I know this? We go to the periodic table. We find magnesium right here, 12. Group 2, all of the elements in group 2 here have 2 valence electrons. Iodine has 7. Iodine's right here, and the halogens in group 7. All of these guys have 7 valence electrons. So iodine right here. So here's the thing that makes this guy tricky. Is iodine can only accept 1 valence electron. Why? Well, it has 7 valence electrons, and it only has 1 empty spot. So 1 empty spot allows for 1 electron from magnesium. So 1, 2, 3, 4, 5, 6, 7. Okay, so we still have 1 empty spot here that we can give to this electron. We give to that electron. Iodine now becomes negatively charged. All right, so what do we do with this this electron over here? He has nowhere to go. Magnesium's still not happy, right? Magnesium still needs to give away this one electron to bump down that energy level and have a full valence shell. So what we'll do is we'll snag another iodine atom. So we'll have two iodines actually. So one, I'm not very good at drawing with my mouse. 2, 3, 4, 5, 6. Ooh, that's going to be a big electron. And 7. All right, so we have 7 electrons here. And now we're able to give away magnesium's second electron. And so now this iodine becomes negatively charged because it's gaining that negative electron. And magnesium has lost 2 electrons, so now it's becoming positively 2 charged. And so now these guys, so again, magnesium, there's a kind of misconception going on in class today that magnesium is just floating around now by himself, a positive 2 charged ion, and then the 2 iodines split and go their opposite ways as negatively charged ions. That's not true. Magnesium iodide is a compound, okay? So it would look like Mg, and then we'd write I2 because we have 2 iodines in this compound here. Okay, so then, like I said, this negative charge is attracted to the positively charged ion. This negative charged iodide is attracted to magnesium still, and they stick together. They form these chemical bonds. Okay, we form our chemical bonds here. And this is how these guys are attracted to each other. Potassium iodide. So we know potassium has how many valence electrons? He has 1 valence electron. We know this right here, potassium group 1 valence electron. Iodine, we just did iodine. We know that he has 7 valence electrons. 1, 2, 3, 4, 5, 6, and 7. All right, so we know that potassium would rather give up this 1 electron, give it to iodine. Iodine now has its 8 valence electrons. It gained an electron, so it becomes negatively charged. Potassium gave up that electron, became positively charged. Now these oppositely charged ions, potassium iodide, will now stick together and form a covalent bond. So it'd be potassium potassium iodide. All right. So that's what you should have gotten for your homework that you turned in, hopefully, by now. Okay. Now what's going to go on is you guys, I will grade this next section. So you guys need to do sodium oxide, calcium chloride, and magnesium sulfide. Okay. So sodium oxide will look a lot like this one. So anyways, that one will look very similar. This one will have a double bond. See if you guys can get that figured out, that double bond. Calcium chloride. Calcium chloride will also look very similar to magnesium iodide as well. Okay, so there's going to be more than just 2 atoms there. But you have to use the atoms that are here in the equation. Okay, you can't just snag an atom from random, right? All right, and then I decided we're just going to hold off on these covalent bonds on this 3rd page for now, and we'll go ahead and finish this whole packet up on Thursday. So make sure you get what you have to do is this whole table needs to be completed, and this second row right here needs to be completed for Thursday. Well, for you guys, it'll be Thursday by midnight. Hopefully that quiz went well. People in class thought it was okay. So I'll go ahead and try to get that graded as fast as possible. We also did notes today in class. I'll put those up for you guys so you guys can go ahead and write those skeleton notes, and I'll have that due as well. Okay.